Hey everyone, I'm Arslan. I'm a solution architect at Red Hat. And today I'll be demoing a machine learning use case on OpenShift using the validated pattern framework. Today we'll be building a credit card fraud detection model. Where based on these 7 values like distance from home, difference from last transaction, we will predict if a transaction was fraudulent or not. Now the workflow looks something like this. We'll start by training the model on a dataset using OpenShift AI. Then we'll push that model to model registry, MLflow in this case. Then we'll serve that model using model mesh in OpenShift AI. And lastly, we'll consume that model via simple application. And in order to achieve that, we need to create some namespaces, install some operators, and deploy some applications. Now, all of that has been converted to a pattern already, which will use a GitOps approach to deploy these different components onto OpenShift. We only need 3 things for today's demo. An OpenShift cluster running in AWS, and locally I have Podman and OC client installed on my laptop. So this demo has 4 main parts. We'll start by deploying the pattern onto OpenShift. In second step, we'll train the model. In third step, we'll serve that model using model mesh in OpenShift AI. And lastly, we'll see how front-end application can consume that model. I will be following the steps on validated pattern website. You can see the link at the bottom of the slide. Now let's start with deploying the pattern. For that, I have opened the terminal on my laptop. I'm logging into my OpenShift cluster. I make sure that my Podman machine is in running state. After that, I will clone the pattern repo locally. You should first fork this repo and then clone it so you can make changes as well. Now change the path and start the install. This step will take 20 minutes to complete. Once completed, log into OpenShift cluster, and if you click on 9 dots in the menu bar, you will see the links to the different components that we'll be using during this demo. If you go to cluster Argo CD link, you will be able to confirm that a pattern has been successfully deployed and it is in sync state. Now that the pattern has been deployed, let's move on to training the model. I will log into my OpenShift Data Science web console, create a project and workbench. That will give us access to Jupyter Lab, where I will clone the pattern repo and run the Jupyter notebook named model. Now I am in my OpenShift console. Click on 9 dots and open Red Hat OpenShift Data Science link. I will also open MLflow, and you can see right now that it is empty. Back in Red Hat OpenShift Data Science console, let's create a data science project. I will name it Credit Fraud Model. Next, let's create workbench. Name it the same, Credit Fraud Model. Select Standard Data Science as notebook image. Keep deployment size small. I will set an environment variable so that my workbench will have access to MLflow route. Key should be named MLflow_route, and I will get the value by running this command. You can get this command from the instructions on the website. Copy this output and paste it in value. We don't have to change anything else, so just click Create Workbench. Give it a couple of minutes before the status changes to running. Once it is running, open the workbench. This is a Jupyter Lab environment. Next, clone the pattern repo, navigate to Model Notebook. In this notebook, we'll start by installing all the packages that we'll need. This notebook will have access to MLflow route that we set in environment variable earlier. Load the dataset, split it into training and testing. Build the deep neural network model. Create a new experiment in MLflow. Train the model in this cell. At the end, before pushing the model to MLflow, we'll convert it into ONNX format, as it is one of the supported frameworks when it comes to model serving in OpenShift Data Science. Let's run all of these cells in the notebook and wait for the training to complete. Once completed, navigate to MLflow and refresh the web page. Now you'll see a new experiment. Click on it to see the first run, and click on this run, and under artifacts, you'll see the trained model. In the next step, we'll be referencing this model through this full path field. We are halfway through this. Our pattern is deployed and the model is trained. Next step is to serve the model using model serving in OpenShift Data Science. To serve the model, I will add a data connection, configure a server, and deploy the model. I am logged into my OpenShift Data Science console. I am still in Credit Fraud Model Data Science project. Let's start by adding a data connection. set the name as MLflow connection. I will get rest of the values by running these commands that you can get from the instructions on the website. Fill up the form. Select credit fraud model in connected workbench and add the data connection. Next, add a server. We can name it credit card fraud. Select OpenVino model server as a runtime. You can increase the replicas or the server size according to your needs. I'll keep everything else as default and add the server. Last step is to deploy the model. Let's name the model credit card fraud. Select ONNX as the model framework. Use the previously created data connection named MLflow connection. To get the path, navigate to MLflow tab and copy everything after the first slash. Paste it under path and click deploy. Give it a couple of minutes and you'll see a green check mark under status. Once you see the green check mark, it means the model has been successfully served using the model serving in OpenShift AI. We are on to the last step. In this step, we'll consume the served model using the simple application. As part of the pattern, we have already deployed this application. Navigate to OpenShift console and click on 9 dots. Open the inferencing app. This is the Gradio app where we can input the values and get a prediction if the transaction was fraudulent or not. If I use the first example and click submit, I should get an error as I have not yet provided this application with the endpoint for my served model. In order to get the endpoint, navigate to OpenShift Data Science console. In Projects, under Model and Model Servers, click on Internal Service and copy the REST URL. Now go to OpenShift console, go to Deployments, make sure the project is Inferencing App, click on the Inferencing App deployment and open Environment. Here make sure you have an environment variable with the name inference_endpoint. And in values, paste the REST URL. Append this URL with /v2/models/creditcardfraud/infer. Then save it. Once done, go back to the inferencing app and submit the values from an example. Now we can see that it has made a not fraud prediction using the served model. If I change any value like distance from home and submit again, we get a fraud prediction. This brings us to the end of the demo. We saw how validated pattern framework made the whole deployment process a breeze. Capabilities that OpenShift Data Science brings to model training and model serving. How different personas from developers, data scientists, and MLOps engineers can use OpenShift platform, and how it can support various workloads. I know that you will have much more complex use cases, and this pattern can be a great starting point. So we are excited for you to try it out, make it better, and share your experience. And that's it for today. Thank you for watching, and I'll see you next time.